Hello everyone, welcome back. Today we are going to talk about displays. We have been dealing with a lot of output devices so far, showing outputs via lights primarily with LEDs, NeoPixel light strips, and we have also seen sound by making sounds with our buzzers and our orchestra signboard. But really what you want to add in your microcontroller project is something to show information to the user. And there are lots of options. In fact, way too many options. As you can see over here, I have a plethora of displays, and these are just a few of the different types of displays you can get for your project. Unlike in a computer where displays have specific connectors that you can use, there's fairly standard. With displays, there are microcontroller displays, there are a whole bunch of different options. So you have SPI, you have I2C that we have sort of talked a little bit about, but there are all kinds of communication protocols between these displays and the microcontroller. We're actually going to focus on one that is called I2C, or inter-integrated circuit communication. And you will see why that's nice. But there are many other options as well. And these displays come in all kinds of form factors. You have fairly big ones like this one, which is a 320 by 480 pixel display. And that's about the limit of the Raspberry Pi microcontroller, unless all you want to do is show something static, because the microcontrollers just do not have enough memory to deal with uh, what is needed to show things on a display. But we'll stick with fairly small displays for the next few videos. Maybe in a future video, we can talk about how to handle something like this, where you're have a lot of pixels to show. But as you can see, they come in all kinds of form factors. They could be color, they could be monochrome, like this one is totally monochrome. This one looks like it's color, but it's actually just two colors. It's got OLED black and the the blue in front. There is, of course, displays that have just LEDs across the screen. So this one has an 8 by 8 display, similar to this one, which is a single color 8 by 8 LEDs. Some of these have lots of pins to connect, right? Um, Lots of pins. Some of these are raw, so you really need a driver chip in addition to the display to use them. The ones that we will use are nice because they only have really 4 pins to deal with. And we will talk about that construct. The I2C uh, is the one that we would use. So to talk about displays, let's quickly look at the main classes that we would need for using a display in our microcontroller project. The primary class for displays in the Pico library is called displays.py, right? And the top level display class is called display. And just like any other object-oriented applications that we have built and objects that we have used, most of the things that we would be doing with our display classes is identify what kind of display it is, right? So depending on which of these displays you've got, you have to pick the right display class object and then create an instance of it. And once you create an instance, we're going to call methods to do things with the display, like show things on the display and so forth. So today we're primarily going to focus on this one, which is an LCD display, which displays 2 lines of text. And we will see how to use this in our applications. So, so here is the display class, which has, of course, simple methods like reset, clear, show number, show text, and scroll. So those are the 5 primary methods. And as you can see, the display class doesn't implement any of these. The display class is kind of a bare bones top level class, and you really do not want to create an instance of this guy. You want to create an instance of a subclass that has all of the additional functionalities. So the one that we will focus on is called LCD display, which, as you can see, is a subclass of display. So it will have all of these methods: reset, clear. They're more or less the same thing. You will see what the two are slightly different with. And then we will primarily look at show text, but you can show numbers, which is really, you can show a number as a text as well, but sometimes it could be useful to have a different for number. And then scroll, that kind of scrolls the text across the display. Now, to create the LCD display, which is this one, there are, again, multiple variations of this same LCD display, as you will see. But the one we are going to use is the I2C or I2C display, which basically uses two lines, two data lines, an SDA and SCL lines. There is a variant of this display that has parallel connections. So you have a whole bunch of lines that you can use. The LCD display class in the Pico library can handle both of them depending on which of the parameters that you pass it. Internally, it figures out how to deal with the connection. So the idea is that all you have to do is create an instance of the class and then call the methods to do the things that it needs. All right, so let's take a look at how you would add a display to your project and how you show simple things to the display. So let's create a new project, and I'm going to create a blank project today so we can show you exactly what you need for it. So here's the simplest raw project. I'm going to rotate this so it's sort of on the side, and we're going to add a display. Now, if you search for, as you can see, there's already a whole bunch of displays that you can see. We will need this one, 16 by 2 I2C display. As you can see, here is the standard 16 by 2 parallel connection. So that requires a whole bunch of pins. This one is easy because it only has 4 pins. So let's add that. And here it is. Here's the display. And as you have the 4 pins, and the pins are fairly straightforward. It's got ground. Today, I'm not even going to bother with a ground bus. I'm just going to connect ground to one of my ground pins. I'm going to connect VCC to the VSys pin. Of course, on the simulator, you can connect it to 3.3 volts, but these displays really need 5 volts. And then SDA, and the moment you touch SDA, you will see all the SDA pins light up. I2C is very well supported in the Raspberry Pi Pico. In fact, there are several I2C channels. So you can actually connect multiple displays to the same Pico. So as you can see, all these SDA pins are lighting up. We're going to take the first one, which is pin 0, and then SCL, the clock line, and that one we're going to connect to pin 1. And these lines do come in pairs. So SDA 0 pairs with SCL1 and so forth. Let me just quickly change the colors of these so that they're a little easier to see. That's all you need. 4 wires to connect a display to the Raspberry Pi Pico. So now, how do we work with the display? Again, the concept is pretty simple. Today, we're not going to go into major details. In the next video, we're going to actually build a real application with these things. So today, we're just going to see how to use the display. So as I said, you will need few files. So we're going to upload some files. Of course, we will need the displays.py, and we will need the log.py as usual. Every display needs some drivers. And it turns out for these I2C LCD display, in fact, for these LCD displays, we need 3 files in addition to the displays.py file. Now, these guys, these LCD API, Pico I2C, and GPIO LCD, these are not written by me. These I have downloaded from GitHub, from other free open source projects. So I'm putting all of them here so that you have one place that you can download files that have been tested and known to be compatible. But the sources of all of these are in the individual files if you want to look at updates to these individual driver files. So I'm going to upload these four, and now we are ready. Now we are basically ready to test out our display. So let's just write just some simple lines of code. Let's say the first thing we're going to do, as usual for everything that we use, is we're going to create an instance of our display. So we'll say my display equals LCD display, and we will send SDA equals 0, SCL equals 1. And once we create the display, we can try a hello world. My display dot show text hello world. Of course, we do need to import from displays, import stop. And we run it. And there it is. There is our hello world written on the display. Now, instead of showing the text, we can also scroll the text, right? If you do that, and if you do this, I can put lots of other things. This is a great display, right? So now if I run this, now you'll see this text scrolling through the display. Yeah, it is pretty slow because the I2C, first of all, it's a serial connection. Second, this is a simulator. Of course, on the real hardware, it'll be a little faster, but still do not expect, 60 frames per second type of scrolling speed. So that's essentially how it works. Let's look at one more thing before we break. That's kind of fun. For example, if you want to show graphics. Now, this particular display is a text-based display. There is no real graphical capabilities on this because it basically shows 2 lines of text. But there is some limited option. So let's take a look at that. In fact, there is, if you look at the source code, there is one method in here called add shape. Okay, so what we would do is we are going to add a shape, and you can create your own shapes by going to this site, shape creator. And if you go here, it's gonna give you a simple 5x8 board that you can create whatever shape you want. Does it look like a leaf? We will see if it looks like a leaf. So let's say this is the shape that we want to show. And what this would do is it's going to create an array. And this is the array that you need for showing this shape. And then what you do is you go into the project, and the documentation basically says you call add shape and then you show the text. So we're going to just show that text here. We will say shape equals, and this is an array. So I'm going to paste that sequence that we created from that page in here. And I'm just going to put this in one line so it's easier to see. And then we will say my display dot add shape. And this is going to go in position 0. And that's the shape that I'm adding. Now, once we are ready, we can just say my display dot show text. And you can show a single character or a string. So let's say I just want to show that shape that I just created, and I want to show it in kind of in the middle, the second line in the middle, right? So row 1, so this is row 0, this is row 1, and this is 1, 2, 3, 4, 5, 6, 7, let's say 8th position. Okay, in the 8th column. So you should expect that leaf to show up here when I run this code. So let's run it. And there it is. Does that look like a leaf? Kind of. But that's almost looks like a face, doesn't it? But that's basically what you can do with this display. But as you would see that these displays are very popular because you can show quickly some information to the user that you need to show. So simple video. Hopefully you got something out of it. In the next video, we're going to put all these together and create an application that does something useful. I'll see you in that next video.